see, let's introduce our next speaker. I believe his name is Andy Dennis, and he's going to be speaking on a basic guide to COBOL security. So if you're on the CTF right now and you're struggling with those COBOL challenges, you might want to check this out and learn some new stuff about an ancient language. All right, so without further ado, Andy, thank you. Let's get started.
All right, thanks a lot. I'm just going to put the slides, assuming I can find them. Oh. Oh, okay. Roman, any idea why I can't share slides?
Yeah, you should be able to hover your video and click on the share screen option.
Yeah, it doesn't seem to be working.
Are you running COBOL right now? Because that could be the problem.
Okay, that's kind of odd.
Does it give you the option?
Yeah. All right, but yeah, it's not letting me share them. I'm not sure if there's any reason why that would be.
What browser are you on?
I'm on Firefox. Let me try reconnecting quickly with Chrome and see if that makes a difference. All right.
Yeah, Chrome seems to work better.
The technical difficulties here. There we go. Right, can you all hear me okay? We good, Tom?
Yep, I can hear you.
Okay, great. And you can see the slides okay?
Yep.
All right, let's get started then. So, perfect. So the talk today is on COBOL security. It's also a capture the flag in its own right. So keep your eyes peeled. There is a mechanism in the CTF platform to enter secrets you find in things outside of the obvious challenges that are in the CTF platform. And then finally, there's also going to be some hints in here for the COBOL challenges, which you can find on the CTF platform. So I'll just do a little introduction to myself. So my name's Andy Dennis. I'm the Director of Security at Modus Create. They're based in Reston, Virginia, and we do consultancy right across full stack architecture, design, cloud migrations, and then going and also reviewing people's cloud infrastructure for security issues and providing lists of ways of remediating it using better engineering practices and DevOps practices. I'm an organizer at BSides CT. And I actually studied COBOL at school way back in the 90s and then promptly forgot it because I had absolutely no reason to use it after that. We had to write a VHS rental system. If you don't know what VHS is, go look it up. It involves tapes. Modus Create sponsored the CTF challenge, and they're also my employer, so I just want to give a shameless plug. So moving on then, we'll start off with just doing a little background on COBOL, and then we'll start to go into some of the security issues that you may face. So what's COBOL? COBOL stands for Common Business Oriented Language. It's an old language. It was developed in 1959. It was based upon Grace Hopper's work with a previous language called Flowmatic. Became very popular in the banking and financial services industries across the 60s and 70s and 80s. And then it stuck around in the 90s and then into the 2000s, and it's still with us today. It took the approach of making the language more English-like. So we'll see some of the syntax shortly, and you can see what I mean. It's an imperative and procedural language. And then in the early 2000s, support for object-oriented programming was introduced. Many of you have probably heard of it because of Y2K. So around 1984, I think it was, folks realized that perhaps using 2 digits for the year was going to be a problem once we turned into the 2000s. So throughout really the 90s, late 80s into the 90s, there was a lot of work done to patch systems to support dates that looked like the one on the left, which is 2000-0101 and not 000101. That might be a hint for the COBOL challenge, so keep that in mind. The language is divided into what are called divisions and sections. So if you look for a COBOL program, you're going to see things like the identification division at the top, which contains the program name or program ID, the data division, which is a section that's used to store the data within the program itself. And then within that, you'll see sections. So one section is called the working storage section, which is where you have variables. And something else called the screen section, which is where you can do your UI and screen layout and then display that to the user. And then the procedure division is kind of where all of your execution of your logic and your code takes place. There's many other parts of this, which is far too extensive to cover in this talk. But if anyone's interested, I will point you towards some documentation, especially in the channel on Discord after, if you want to start digging in. So I mentioned that the language is still around with us today. There was continuous additions made to it. So in 2002, we had COBOL 2002, which was a bit of a flop. They added recursion to it, lots of new reserved words. It's been sort of picked apart in a conference paper called The Good, the Bad, and the Ugly by folks from IBM. So if you're interested in reading about that, I'll provide the link. And then in the later half of really the last decade, IEEE 754 data types are supported, and then things like method overloading. So the language has progressed over the years. It's just been slow. But because it's still around, obviously people have requested new features and they gradually get incorporated into the language. So it isn't obsolete. If any of you have been following the news this year, you'll have seen that New Jersey and Connecticut, amongst other states, had a lot of problems because there was a huge number of folks applied for unemployment and the systems just couldn't keep up. So I believe it was the governor of Jersey was on TV asking for COBOLT programmers because even he wasn't aware what the language was because it's quite old. And there was a shortage and they needed folks to come in and help upgrade the systems in order to keep the demand. But it's not just state systems. There are banks and lenders and all sorts of financial institutions in New York and elsewhere that are still relying on COBOL. And the tri-state area is probably absolutely riddled with it. Because we have the insurance industry in Connecticut and then obviously banking and finance in northern Jersey and New York City. So it's all over the place. Apparently, there's lots of jobs in COBOL in Hartford, Connecticut, if you're looking. I took a look, I think it was last night, and ZipRecruiter had 280 plus jobs listed on it. I'm sure some of them are duplicates, but it should give you an idea that there is some demand up in Hartford still in the insurance industry for folks who have COBOL shops. So it really isn't obsolete. Celent, Accenture, IBM, and some other folks published a report 3 years ago, which was picked up by Reuters, which really sort of dug into some of the numbers behind how COBOL is being used. So currently, it's estimated about $3 trillion worth of daily transactions are handled by COBOL systems. 80% of in-person, so branch transactions, rely on COBOL in some fashion. And 43% of the banking system, so banking, loans, finance, has some sort of COBOL system somewhere in the mix. I've seen the number that there's 220 billion lines of COBOL still in use. This was also reported back in 1997 as 2 billion lines, and they were estimating about 5 billion lines a year were being added. Well, obviously, in the last 20 years, we haven't added 5 billion a year, so it's difficult to know whether some of that code is being deprecated and replaced with more COBOL or whether that's slowed down. But either way, it's a lot. As I mentioned, I'm not too sure about the 2 billion plus lines, but we do know there's somewhere in the region of about 3 million ATMs in the world. And a good chunk of that COBOL code is probably interacting with them. I don't even know. Maybe it's even running on some of the old ones. I'm not an expert on how they program ATMs, but they do estimate that COBOL handles around 95% of all ATM card swipes. So that's a substantial amount of transactions that COBOL code is responsible for. And there's plenty of other older systems out there that are running it. If you're interested, check out this report. Federal agencies need to address aging legacy systems. Some of these systems in this list go back to the 1970s. I believe there's one even in there, the Department of Defense, that might even be from the 1960s. So it's pretty crazy. You know, we've got these embedded legacy systems all across different industries, whether it's finance, insurance, and then into the government, and they all need to be maintained and patched. So the big one is the IBM mainframe. I see someone in the chat mention that they're still running IBM mainframes. If you check out the job listings, you're going to see ZOS is listed and IBM mainframe. So mainframes aren't just these big cool computers from war games and 80s movies. They're still in use today. IBM Enterprise COBOL deployed on ZOS is a common approach, and it supports interlanguage interoperability, so it can talk to Java. So basically, you can have a bunch of Java microservices talk to the COBOL backend, and then in turn allow newer technologies to communicate with all that data that's sitting there, and algorithms and whatever that's involved in, I would imagine, insurance calculations and credit scores and so on. So that brings its own pros and cons. You can have a web interface that can pass data eventually back to the COBOL backend via Java. But it also introduces its own risks, as now the system is, in theory, exposed via these intermediate tiers. That is going to impact all the engineers on a project, because if you're working on a web front end, whether it's Node.js, Ruby, Python, any of those languages, and at some point you have to collect data and it has to get passed back through the system, the COBOL system goes down, then that's going to impact what you do, but also, they're kind of relying on you. So there's definitely some security concerns at these various parts of the ecosystem that's being built out. So what do you want to do if you want to experiment at home and you don't have an IBM system? So let's say you kind of fancy learning some COBOL because some other folks in your company are doing it, or you just want to, learn it because you figure, hey, I might want to get a job doing this at some point. You don't have to have an IBM system. You can use something called GNU Cobalt. And GNU Cobalt used to be called Open Cobalt. It's open source. It's built on C, and you can write and deploy COBOL programs locally, or you can put them in Docker containers if you like. And then on top of it, you can call other C programs from inside your COBOL. So if, for example, you write a capture the flag challenge and you want to call another C program you've written, you can quite easily do that. And here's a little example for you. You can see here on the left-hand side, we're calling this function, we're calling this program actually called decrypt users. And then the C program, here's a snippet of the code on the right-hand side that's being called. So you can see that we can do some interaction with files on the file system, and then pass that data actually back into the to the COBOL program from the C program. And if you want to run it in Docker, it's actually relatively simple. You can just pull in an Ubuntu image, install the Open Cobol. Notice it is called Open Cobol and not GNU Cobol. And then you can copy your file over into the container, run cobc against it, and output the binary file. And that's actually how we built the CTF challenges for BSides 2020, was they're all done locally in Docker containers and then are now deployed in the AWS environment using, I think it was ECS. So if you do want to do some development locally, you can also use the VS Code plugin. This allows you to do editing, viewing, compiling. You can see on the right-hand side as well, it will do syntax highlighting, and it will give you a breakdown on the left-hand side of the IDE. The various sections I was telling you about, so identification division, environment division, data division, procedure division. So it just helps you to develop in a clean, easy fashion. I used Vim for a lot of the development because we weren't doing anything super complex for the challenges, but something like this is great if you're developing locally. Apparently, you can deploy COBOL now in Azure. Microfocus, Visual COBOL. If you take a look at this link, you can deploy it in the Azure environment. That's something I'd quite like to try, and perhaps next year, if we do another COBOL CTF challenge, we can give that a crack. So what are some of the issues then an engineer might face who has to work with a COBOL backend? Perhaps someone's deployed it in in Azure, or they've got the IBM system running in a data center somewhere. So let's move on and take a look at some of the security issues. So high-profile breaches involving COBOL have allegedly happened. The Office of Personnel Management in 2015 had 4 million records leaked. OPM was facing a huge problem with legacy systems at the time that required modernization, and COBOL was cited as a contributing problem to this, or contributing factor. I don't like to necessarily blame the programming language. I think it's probably more just mismanagement and a huge mess over the years, people not maintaining systems and migrating them when they should have done. But if you're interested in reading more about the hack, you can read it here. So I guess we should probably worry about security, right? And the answer to that is sure, but in the same way as you would any system, especially any system that has the infamous cloud sitting in front of it, or is exposed to the public internet. So if you have to support some complex web of systems and COBOL is in the mix, you can advocate for deploying some static analysis tools, making sure there's unit tests, documentation, and CICD processes, and that's something I'll touch on in a little bit. There are CICD tools that support COBOL. So let's delve into some of these options. We can use universal security practices. So hiring and training staff and making sure they're aware of things like the OWASP Top 10. We had some of the OWASP folks in the Discord channel, so feel free to reach out to them if you'd like to learn more. We can follow just general good engineering practices. I mentioned documentation, unit tests, integration tests, source control, all of those tools. They're not specific just to modern languages. They can certainly help us with legacy languages like COBOL or Fortran or any of the others that you may come across. We can do threat modeling, which we'll cover a little bit in this talk. And we also can buy tooling to help us out. So there are modern tools which allow us to do static analysis and similar on COBOL code to highlight some of the problems that may have been introduced in the past or that newer engineers are introducing. So one thing I saw when I was doing some research was that some of these systems are so old and complex that they lack documentation. And this actually contributes to making the migration and the maintenance really difficult and costly. It also results in some of these migrations partly failing and costing hundreds of millions of dollars. One story that was in the press a few years ago was TSB, which was a UK bank, and I believe they merged with a Spanish bank, and they had to bring the two systems together, and the whole thing just fell over. It was a complete mess. So lack of documentation can really make these modernization projects and security patching very difficult. So as a result of that, it just throws more fuel on the fire about having to maintain these systems. So I think we're probably going to see COBOL around for a while yet. And especially, if there's a cost impact with migrating it, banks obviously are quite concerned around risks, so they're not going to want to go shutting systems off that essentially contribute to their bottom line. Someone described it as like trying to replace parts on a plane while you're flying. So one area I guess we can start with is going back and documenting that code, having people sit and read the source code and document it so we actually know what those legacy systems are doing, and they're not just sitting there churning away and everyone's crossing their fingers that they don't break. You also can't fix bugs if you don't have staff. Engineers are retiring. So as I mentioned, this language came about in 1959. A lot of the folks that were sort of in its heyday, the cream of the crop engineers are retiring or have retired. So the number of available folks who are skilled in COBOL programmers is shrinking. And this is a huge risk. You can't plug security gaps if you don't have folks who are cognizant of security issues, but also well-versed in the language in order to be able to patch them and stay on top of modern techniques for ensuring that the code and the systems themselves are secure. So it does look like we're probably going to need more COBOL engineers. That certainly seemed to be the case with what happened in Jersey, where they just had a shortage. So in the interim, cross-training staff might actually help. If you have folks who are responsible for writing that Java code that interacts with the COBOL backend, making sure there's cross-training there can at least mean that you have backup resources and people that understand how that data flow is going through the systems and then ending up in that backend system on the IBM mainframe or wherever you have it housed. So the next thing I want to talk about is threat modeling. And this is really figuring out what interacts with COBOL. If you're running mainframes and you have cloud systems in front of them, you need to understand those data flows I mentioned. You need to understand all the various components in the system and the touch points. Are you sending data to Java and then onto COBOL systems? Does it contain PII or does it contain any kind of financial data? ATMs, of course, have their own risks. I'm not sure how many of us are working on legacy ATMs. I wouldn't even know where to start to know what the issues are. It's a complete area of mystery to me. So I'm sure that threat modeling around ATMs and how they interact with the other systems is probably quite a fascinating area if you can get into it. And as I mentioned, COBOL engineers are retiring. This isn't the 90s or the Y2K area where we had lots of folks who were constantly working on this and had a lot of experience. Individuals are retiring. That in itself is a threat and a risk. We can use some threat modeling methodologies to take the existing COBOL systems and the various things that talk to them and map out the threat models. There's PASTA, Stride, VAST. I'm sure some of you have heard of these various methodologies. And there's tooling that supports them. And I'm going to touch on that in a moment, actually, because I think that can be quite helpful. So there's tools like Threat Modeler and Iris Risk, and then OWASP has its open source Threat Dragon tool. I was poking around a Threat Modeler, and you can actually, if you're not familiar with the tool, you diagram out systems, and it will generate a list of potential threats based upon the components in the system. You can actually add in the CPE IDs for ZOS and for COBOL servers, such as the Hitachi COBOL 2002 Net Server Suite 01-3. So if there are known issues associated with that, when you attach the CPE ID to the component in your model, it should give you a list of potential vulnerabilities and threats associated with it. So diagramming out the system can actually help you to visualize where, hey, okay, now we've got these other components and potentially human interactions with it. Where are those issues likely to come from, and how can we then get ahead of it and patch it and fix it in advance? Martin Fowler, who I'm sure many of you are familiar with, he has actually a great post on threat modeling, which came out this year. So if you're interested, definitely check this out. It's totally applicable to languages beyond COBOL. So that, there really is no reason not to throw your COBOL system into the mix when you're threat modeling solutions going forwards, if you have COBOL systems, of course. The next thing I wanted to touch on was testing in QA. Of course, we all know engineers love writing unit tests. So you should be adding unit tests to your COBOL programs, just like anything else. The Open Mainframe project has some material on their GitHub page. It still looks like it's under development. They've got 3 training sections on there. The first portion it looks like it's complete. The second and third portions are still in development, but I would keep an eye on that. There's an IBM Labs link you can go check out and play around with. And then there's also something that's old but worth looking at is this Neopragma GitHub repository, which has COBOL unit test examples in there. So you might get some ideas from there to go figure out how you might want to write tests for older code that perhaps you've been given to maintain or have to interact with. So functional and integrated tests, I think we're all probably familiar with them. If you're not, really, this is about when you introduce new features, making sure all the new components talk to each other, that there's no regressions introduced, and that the new functionality that you've included works. So this can also include integrating with other systems. So perhaps you change the COBOL backend and you have to make sure it still works with the Java system. So that's all really kind of important, not just winging it. It's same with any engineering projects, really ensuring that you have solid QA and unit tests and integration tests and functional tests can make life a lot easier and help to pick up problems before they hit you in production. So I did mention CICD Microfocus. They have some tools for doing this. The main Open Mainframe project book discusses it too, and I actually poached this diagram from their GitHub repo, and it looks like they're building out more information around that. So here we can basically integrate our code into a pipeline that builds, tests, and deploys the COBOL. And also we can include static analysis in there. IBM has a product called Urban Code Deploy, and you can see it within this CI/CD diagram. You've got a lot of modern tools in there you're probably familiar with, like GitHub and Jenkins and Artifactory. And then you can deploy it onto those IBM-based systems, which you can see up here at the top of the up here at the top. So I mentioned static analysis. So that can be a really great and important part of this sort of DevSecOps pipeline. So there is support for COBOL and Enviro products. Microfocus does. SonarQube has support for COBOL. If you didn't get the chance, check out John Williams' talk, who was on a little while before me, because he has a good talk on SonarQube. As much as there may be flaws with it, it does support COBOL, so I'm going to give it a friendly shout out here. And of course, the nice thing is if you invest in static analysis as part of a CICD DevSecOps pipeline, you can analyze not just your legacy code, but you can analyze modern code as well. Many of the sort of server install versions of these, as opposed to the cloud versions, allow you to construct your own rules as well for scanning for vulnerabilities. So if you start to discover things yourself over time, you can build them into the pipeline and then scan for them and then ensure things don't get moved into production where there's potentially secrets included in the COBOL code or similar. So things to be concerned about. So some of the stuff that the static analysis tools actually look for, things that are similar to what we find in other languages. So avoid adding SQL directly into all of the COBOL code all over the place, because it makes maintenance a real pain. If someone goes and changes a table name or similar, it's going to basically break all of those pieces of COBOL that have this embedded SQL. We tell people not to do this in PHP and other languages, so don't do it in COBOL either. Use a data layer instead. And also, SQL injection attacks can be a problem with unsanitized inputs. So don't fall into the trap of using dynamic SQL. That's same as PHP, right? In those languages, we perhaps use an ORM or similar. So the static analysis tools like SonarQube are going to flag that. The Sonar source rules specifically are going to flag for dynamic clauses, and are going to highlight potentially insecure usage of like select statements where they're lacking a where clause. Another thing to avoid using is the accept statement. Accept will, as the name implies, accept any input and doesn't sanitize it. We can display data to a user, we can accept a response, and it will just load the data straight into that working storage section I showed you earlier. And I'm going to show you a quick demo of this just to emphasize that. So remember we mentioned the divisions. So this is part of the screen section in one of those divisions. And here we can see all we're asking for is press the Q key to exit. And that gets dumped straight into this response input. Pick X is basically expecting one character, and then it moves it straight into the response in settings section of the working storage, and there's no sanitation there. Obviously, with longer strings, you can imagine the sort of problems you might encounter. And in this case, you can see below, what we've done is we've displayed this. Obviously, this is just a subsection of the screen. We've displayed the stat screen, and then we're just accepting that input. So, I mean, it's a very, very simple way of displaying and accepting data, but it's also quite risky. And as I mentioned, don't use just display either. It's recommended to avoid doing that if possible due to the risk of displaying sensitive data. So basically, combining display and accept and not sanitizing data is risky behavior in COBOL, and your static analysis tool will likely flag that. Another thing not to do is use the debugging mode, switching it on in production. So like other frameworks and languages, don't leave the debug statements in, as they can expose information about the system to attackers. So this example here is a bad idea because we've got debugging mode on. I've seen this done in other languages, and then someone comes along and hits the website and causes it to do a stack dump, and they find all sorts of goodies hidden in there. So keep that in mind when you're working with COBOL. Don't make the same mistakes. Don't programmatically insert subprogram names into at runtime. So here we've got an example of we're moving the subprogram name to my subprog, which is a variable, and then we're calling it. So that's a bad idea. Make sure that you define the program name not as a variable and then call it directly. because otherwise this can just be misused by attackers, and you can dynamically insert a different program in, and you just don't know before runtime what's going to get executed. There's a bunch of other bad practices too, and there's tons of ways to break your code, which aren't necessarily just security issues, but could be leveraged, just by a bad actor to bring your system down to denial of service hit. There's likely lots of COBOL applications running which don't involve any kind of disk encryption, or the databases that they're talking to aren't encrypted. There's a few examples in this link here if anyone's interested, and I will share all of these at the end, so you can go do some reading if you want to follow up. So I mentioned training, so let's go on to that section next. The Open Mainframe project has a whole bunch of resources on their website. So I'd say, I know we've got a whole bunch of students signed up from UNH and Southern and some of the other universities in Connecticut and probably further afield. If you're a student and you've got spare time, which I think a lot of us have ended up with thanks to COVID, you might want to go and have a go at learning some COBOL and getting it on your resume. The worst that happens is you learn something. The best that happens is your combination of COBOL skills plus something else helps to land you a good job out of college. Or if you already have a job, helps you to move into a slightly better position or something like that. As I mentioned, there seems to be a lot of jobs around at the moment in the area. Not a lot of people apparently are going into the field, so that could be an area to help you grow your career. As much as it's not as exciting as Go or Rust or any of the other languages in flavor at the moment. The Open Mainframe project, which I just mentioned as well, you can go to their GitHub account. It's here at the bottom. I'll share that, and you can clone stuff from there and go off and have a read of it. So there's plenty of information in there, which is super useful. So our CTF challenge. So this year we added a CTF challenge that was built on COBOL. We can't promise you it will have all the security flaws in here, although with our poor COBOL programming skills, who knows? We might have used accept in there. The Open Mainframe project also has COBOL challenges if anyone's interested in doing, some extra almost kind of CTF style things after this. Take a look at these links and go have a play around because they're kind of good fun. Right, and that was, I think I'm within my 30 minutes, 40-minute window. So that's a basic guide to COBOL security. I hope you found it interesting. Gave you a little bit of insight into COBOL usage now and some of the basic security considerations to keep in mind. Hopefully this has been useful if you are doing the COBOL challenges. Just some areas I will highlight. Keep in mind what we mentioned about being able to call C programs. If you've done the Git press challenge, that may be a hint. Keep in mind what I mentioned about dates at the start. That's another hint. And also, there was a flag hidden in there, and if you spotted it, remember you can go to the CTF platform and enter it in there. And if you have any questions, head over to the Discord channel, and I will be more than happy to answer them there, share links, resources, and thanks to the BSides CT team for putting this on this year. And that's it. So back to you, Roman or Tom or whoever's handling it as the MC.
All right, thank you so much, Andy.
Sounds good. Right.
That's an awesome talk about an ancient language, but obviously still widely used. So definitely.
All right.
No.
I will see you at the CTF.
Yeah, everybody hop on the CTF and try out those COBOL challenges. I'm 100% certain you'll learn something new on there. I always do.